Hello and welcome to Nikolai's genetics lessons, and today we are going to talk about combinations and permutations, how these two terms are different. And here is a problem. A special type of password consists of 4 different letters of the alphabet where each letter is used only once. How many different possible passwords are there? And here is the variance of the answers. First of all, let's define what is the combinations and permutations, and this picture would help me to explain. And as you know, we call this log combination log, but actually we have to call this permutation log because order of numbers which we put here matters. For example, take a look. Let's say we have 4 numbers here, and our code would be, let's say, 1, 2, 3, and 4. And if we, for example, put a number which is going to be 4, 3, 2, 1, this number is not going to open this log. Only this number is going to open this log. But as you understand, there are many different variants how we arrange these 4 numbers. For example, it can be numbers are 10, but we have 4 positions. For example, this can be 3, 4, 1, 2, and many other variants. So if it's going to be combination log, all this combination are going to be able to open this log. But because this is permutation log where order of numbers matters, it should be called permutation log. Now let's solve the problem. This is going to help, and this picture is going to help us. So we have a log. So 1 position, 2nd position in this log, 3rd position, and 4th position. And we also have rotational cylinders here for each position where we have different, in our case, letters. And we have 26 those letters. And according to our problem, we can choose any letter out of 26, but there is a rule. Letters have to be different. So for example, if for the first position here we can choose 26 letters, 26 letters. For the second position we cannot choose the same letter that is here. Any letter we choose, for example, it can be A, B, C, any letter. We cannot choose an A, B, or C letter here. So we have 25 variants for the second position. And when we will think what can we choose for the 3rd position, it can be any letter out of 26 except 2 letters, which we already choose for the first 2 positions. So we will have 24 variants here. And of course 23 variants here, because we can choose out of 26 except 3. So we can choose out of 23 variants. And our last step would be to multiply all these combinations, and this is how we are going to get 358,800. And this is answer D. I hope my explanation were clear enough, and now you would be able to tell the difference between combination and permutation. In combination, order doesn't matter. In permutations, order does matter. And this affects our calculations. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. And see you in the next video. Goodbye.